AC circuits. Usually, an alternating waveform, a waveform like this. Maybe this is a sine wave, or we can say it as a cosine wave also. V is given by V equal to, we want the instantaneous value of this waveform, that is alternating waveform. The instantaneous value V of t is given by Vm sine omega t. Meenakshi, are you there?
Yes, sir.
Meenakshi, for an AC circuit,
Yes, sir.
voltage we will write instantaneous voltage. V of t is instantaneous voltage equal to Vm sine omega t. Here, what is
Yes,
this
sir.
Vm?
Maximum voltage.
Not maximum voltage. Maximum voltage like that one term is not there, no.
Yes,
Okay.
sir.
Let us ask Divya. Divya, are you there?
Yes, sir.
Divya, what is Vm here?
Sir, measure voltage.
Not measured voltage. It is the peak voltage. Peak. We will say now V peak. This is Vm. Both direction we can take the peak voltage. This is Vm. What is peak voltage? I should write. Peak voltage value we can say. Peak voltage. Then Lakshmi, are you there?
Sir.
Lakshmi, here the phase is given by what term? Phase or angle of the wave?
Angular velocity.
That is the omega t. Omega t. Now I will write V of t of a waveform is given as 200 sine 50 t. So we have a sine wave that is represent, that instantaneous value is given by V of t equal to 200 sine 50 t. Okay. Now Chandru, just 1 second. Let me close the window. 1 second. It is raining here in Bangalore, so power may go off. Okay. Now, Chandru, are you there?
Yes, sir.
Chandru, now another sine waveform is given as V of t, that is the instantaneous value of the waveform, instantaneous value of the wave, 200 sine 50 t. What is the frequency of this this wave, Chandru?
Frequency is 50 hertz.
50 hertz. I have not asked you angular frequency. Angular frequency means it is not angular frequency, unit is radians. We can say 50 radians per second. Now I not ask you in radians. I not ask you angular frequency. Simply if I ask you what is the frequency of given waveform, given equation. Anushri, are you there? Anushri? Dheeraj Shivankar, are you there?
Yes, sir.
Dheeraj, This omega, in which what term we can write it? Omega equal to what?
Sir, I don't know, sir.
Okay. Sahil, are you there? Sahil?
Sir?
Sahil, omega
sir.
equal to what?
Sir, नहीं पता sir.
Okay. Sidhu, are you there? Sidhu?
Yes, sir.
Sidhu, what is omega equal to?
I don't know, sir.
Okay, okay. Arati, are you there? Arati,
Sir,
what is omega?
2 pi f.
Yeah, angular frequency equal to 2 pi f. Angular frequency equal to 2 pi f. Two pi f. Now, here he has given us the omega equal to 50 t. Here omega equal to 50 t. Similar one question they have asked sometime. So it is 50 t. The which equal to 2 multiplied by 3.14 multiplied by f multiplied by t. So t 50 t will cancel, then we can write 50 equal to 2 multiplied by 3.14 f. If we simplify this, 50 divided by 6.28 will give frequency. F equal to 50 upon 6.28. So like this, you should be able to identify the frequency of a sine wave. Now, Adira, are you there?
Yes, sir.
What is the RMS value of the given equation? I'll write it on another page. Vt equals to what we have, 200 sine 50t. Here my question is, what is the RMS value of the given equation? VRMS, you have to tell. VRMS equal to what?
1 by
Clearly tell. Let it, if it is wrong, let it go wrong.
1 by root 2.
1 by root 2. Okay. Let's Sahil. What is VRMS? Subin, are you there? Mohanda, are you there?
Yeah.
Yeah, Mohanda, tell me.
No idea.
Okay. Then who is there? Jagdish. Jagdish.
Sir.
Jagdish. What is the RMS value of the given equation?
Sir, 0.707.
Yeah. It is either 1 by root 2 multiplied by what is this value is given? It is what is this value, peak to peak or peak value or RMS value?
So it's peak value, sir.
It is VP, okay, peak value. So 1 by root 2 multiplied by 200, or it is 0.707 times of 200. Jagdisha, what is 0.70 times of 200? Quickly tell. Jagdish.
Sir, 1.414, sir.
1.414 is the wrong answer.
Sir.
You see, this now this is a let's think that this is a number. We have to find it is 0.70 times multiplied by 200. What do you do? How do you solve it? Let us assume that 100 is the value. If you multiply this 100, what is the 70.7% of 100? How we have to approach it? Okay, with 70.7% of 100 is what? That is 70.7 volt. Once you know 70.7 volt, then what you do? You will take double of it because the voltage is 200. So it is going to be 141.4. Jagadish, it is 141.4 volt VRMS.
Oh, okay.
Okay, how I calculated? I just compared with 100. Then we will get quickly we will get it is 77.7 for 100 volt. Then for 200 volt, we have to take double of it.
Okay.
Okay. Okay. 1 second. Next, Lakshmi, are you there?
Yes, sir.
Lakshmi, what is the peak to peak voltage of this wave, this equation, the wave equation?
2 VM, sir.
2 peak to peak. 2 times the VM. So it is 2 multiplied by VM is 200. So you get 400 volt. So, okay, once more I will write it. One more question I want to just ask the frequency only. Now another waveform V of t equal to once. So V of t equal to 100 sine 314t. Now what is the frequency here? For the given wave equation, what is the frequency? F we have to find. Jaimon, are you there? Prasad, are you there? You have to respond quickly. We should not waste time. Prasad, are you there? Nishant, are you there?
Yes, sir.
Nishant, we have to calculate the frequency of the given wave. This represents a sine wave.
Okay.
This is the peak value. Okay, now you tell me what is F?
Sir, this 314 is what time?
What I wrote the equation. This is V of t of a sine wave is usually given as Vm sine omega t, which equal to
Yes, sir.
Vm sine 2 pi ft. Now you have to calculate the frequency of the given equation. What is the frequency? What should I write? Okay, let's go to the next person. Vasanta, are you there?
Yes, sir.
Vasanta, tell me. We want to find the frequency. So what do you write? First you will write 2 pi ft. Correct?
Yes, sir.
What is 2 pi ft in the given equation? What is 2 pi ft?
2 pi ft in f is equal to
No. What
It's given,
is
sir.
the given equation? What is 2 pi ft?
100 sine 314t.
But 100 is not the 100 sine is not the 2 pi ft. No.
Yes, sir.
What is 2 pi ft? 2 pi.
300,
Tell me.
314, sir.
Fully or not all no. What is 2 pi ft equal to what? 2 pi ft equal to what? 314t. Correct? see,
Yes, sir.
this term is this question they asked. Okay, once simply they can ask. This is equal to 2 pi ft. That is what he has given. Now, okay, okay. Now, Maithili, are you there?
Yes,
Maithili,
sir.
Maithili, simplify.
Yes,
We
sir.
have to get the f from here. How do you simplify?
So leaving f over right side, we 314t divided by
No, now
2
see
pi
when
t.
you have when you have a equation, left side of the equal to and right side of the equal to, we have a equation. Because why do we say this is the equation? Because the equal to sign is there. So this is the left side of the equation, this is the right side of the equation. If there is something
And
to
we-
cancel it out easily, you should cancel it out. So here t we
Okay,
don't
sir.
want, we
T.
can cancel it easily. Then
Okay, sir. And
okay,
2 pi f is there.
now we know 2 pi f equal to 314. 314.
So f is equals to 314 divided by 2 into 3.142.
3.142.
That is equals to is of 314 by 6.28.
And now we want to simplify the calculation because we don't have the calculator. Okay,
Yes, sir.
Jagdisha. Okay, one second. Jagdish, are you there? Jagdish. Jagdish, are you there? This who? Akhil, are you there? Akhil. Akhil.
Yes, sir.
Akhil. Now you see this equation f equal to 314 upon 2 multiplied by 3142. We don't have the calculator. We have to make the simplification much more easier. How do you do? What do you do? How do you simplify?
No idea, sir.
Yeah, Anishri, yeah.
Sir, multiply by 100 in denominator and numerator.
Then we are
So
go.
after
Okay,
three-
okay,
three, one-
okay, okay. So otherwise, what you have to do? Send this 2 to
Sir,
here
directly,
itself. Don't take this 2. 2, let it be there itself. 2f. Now what is there? Let me erase it. See, now we can multiply and divide by 100. We can do 100. So this last 2 we can omit it. 3.14 is sufficient. So it will become 314. No,
So,
I think
sir,
if I write like this, no, let me. You will get confused. Yeah.
sir, on a denominator 3.1, sir, pi value is equal to 3.14. So we will write only,
3.14. 142 also we can take. 3.14 is sufficient.
but sir, in a numerator 314. So can we forgot 3.14 only, not 3.142?
No. 142 you can 42.2 you can neglect it. No issue. 3.14 you can take it.
Okay, sir.
Because MCQ, that much detailed calculation we don't want. We want the closest value.
Yes, sir.
Close value. So now what will happen? This will come to 314 multiplied by 100 upon 314 we will get. So 314 get cancels. So we will get 2f equal to 100. So what is f? Ankit, what is f then?
Sir, 50 only.
Sir,
50 hertz. So this way you should be able to simplify it. For that you need a little bit practice. Once you see the number, what is the easiest way to simplify it? So that we can save time. Okay.
sir,
Yeah.
sir, I have one doubt.
Yes.
Sir, here 3.142 is there, no? So after
Yes.
the decimal, it's 3 numbers, right?
Yeah.
So how we have multiplied 100? After that, it should be 1000, no, sir?
No.
After
See
the
what
decimal,
I have
3
done.
point.
See what I have made. I forgot this point too.
Okay.
It is not there.
Okay, sir.
It is not there because for the MCQ questions we need not to go so much detail. Answer should not go wrong also. Okay, that's how.
Okay. Okay, sir. Thank you.
Okay. That means in previous class you understood how to put it. Okay. Now we have a circuit, a pure resistive circuit. What happens if you apply AC to a pure resistive circuit? Pure resistive circuit. So we have a resistor. We have a resistor, and we are applying alternating current V to this circuit. So V, when you say, that is the instantaneous value. V equal to, we can write it as Vm sin omega t. Sin omega t. Then Maithili,
Yes, sir.
what is Kirchhoff voltage law?
In a closed in a closed
Yeah, in a closed circuit. In a closed circuit, applied voltage equal to
applied voltage equals to
sum of voltage drops in the circuit. That is the Kirchhoff voltage law. So, and see, that is the Kirchhoff voltage law. I think another two circuit we will go little slow. Then immediately we'll just go through the equations only. So here what happens? This alternating current direction will be keep on changing. But at an instant of time, at a particular instant, we will assume that current is flowing in this direction, I. So if current is flowing in that direction, here the potential has to be high and here low. Now, Vasanta, are you there?
Yes, sir.
See what I have told you, just you repeat what I told you just now. Vasanta, this is the AC we are applying. Why I put the arrow like this?
Current flowing to the positive to negative.
But alternating current, direction will keep changing, no?
Yes, sir.
Then how it is? How that arrows come? Because at a particular instant, at an instant of time, current was flowing this direction. That I have assumed. Okay, that is how we are drawing like that. Then I have marked if current is flowing, current will flow from higher potential to lower potential. So then I have marked plus and minus. Okay, now somebody has to apply the KVL. Lakshmi?
Yes, sir. Yes, sir.
Just tell me KVL. Apply KVL in the circuit.
V is equal to
V is equal to
I into R.
I into R or VR, that is equal to VR.
Yeah.
VR. Now, what is I here? I equal to V upon R.
V upon R.
What is the V here, Lakshmi? V is V. This is the
IR.
We can write it as Vm sin omega t. Vm sin omega t upon R. This Vm and R we can write it as I equal to I naught or I naught we will write it as Im only. This is Vm, no? We can write it as Im because these two are like a constant number. This number, this peak value and R is not going to change. So Vm upon R, I have wrote it as Im.
Yeah.
then we get sine
Sine
omega
omega.
t. Now, if there is a phase change, see, the like V equal to
Sir,
Vm sine, yes,
sir,
yeah,
Vm
okay.
sin omega t is RMS value or other value?
See, Vm is the peak value, not the RMS value. Peak value. And V, what is V? That is the instantaneous value. Here, no RMS value. The RMS value, if you want, what you have to do? Vm upon root 2. Then you will get the RMS value. Dheeraj?
Yes, sir.
Okay. No. Somebody asked, no doubt.
Sumit, sir. Sumit.
Sumit. That is how.
Yes, sir.
See,
Okay.
Vm is the peak value of the wave or AC. If you want,
Sir,
you have to-
I'm asking what is the full Vm sin omega t? What is called
that
total?
is called that is I, instantaneous value, instantaneous voltage and instantaneous current. This V what I have mentioned here, this is the instantaneous voltage. The I is the instantaneous current. See, that is related with the T. That is related to T. So it is what? It is a time varying quantity. So that is instantaneous. V is the instantaneous value of AC.
Okay, sir. Understood.
Instantaneous. Okay. Instantaneous value. Okay, now Vm, we got Vm sin omega t. And another quantity we have, that is Vm sin omega t plus pi by 2. And another quantity we have Vm sin omega t minus pi by 2. See here, this part, this sin omega t, that part is there only we can see if there any phase, that gives the phase information. See here, in this voltage waveform, it is actually 90-degree leading compared to the first waveform. And this last waveform, if we see here, this equation, then compared to the first waveform, this is lagging behind the first waveform by pi by 2, 90-degree. That information is there. Now I think you understood this Vm sin omega t, this voltage equation, that is the Vm sin omega t, and I equal to Im sin omega t. There is no phase difference. The phase difference means phase difference. Just some okay. Phase difference. Phase difference means phase of voltage minus phase of current, phase of I, and mod of that gives the phase difference. Here what is there? The previous equation we have omega t. So omega t minus omega t, we will get 0, and that is the phase difference. And now this AC quantities. So here what we say, in a pure resistive circuit, resistive AC circuit. Anshri is not there today. Let me once check. In a pure resistive AC circuit, a pure resistive AC circuit, voltage and current are in phase. 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 Okay, now these AC quantities we will represent using phasors. Phasor, we will say phasor. In depth we don't need this thing, but we should know a simple question comes, we should be able to handle it. For that you have to idea about the phasor. Jagadish, are you there?
Sir,
Jagadish, let's draw this phasor. So this is the time. Okay, so this time I'm not mentioning, okay, because we will take this phasor. No, we need angle only here, angle. So if we take this is a 0 degree, let this is 0 degree. Now, but the given waveform, it is sine omega t. So we can draw it something like this. So this is the phi equal to omega t. And what is this? This is the Vm. This is the peak value. For peak value only, we draw the phasor. And then, so this is Vm. And what about Im? Where do I mark? Now, Jagadish,
sir,
where do I mark Im?
sir, y-axis.
Why do we go to y-axis? Now, Jagadish,
Sir,
in this, see, this is the AC circuit. Okay. What is our voltage equation? Voltage equation is Vm sin omega t. Okay. And
Yes, sir.
I is Im sin omega t. And one more thing you have to understand, the current is always less than the voltage. Is it right, Jagadish?
Sir.
Why? Why current is always less than the voltage? Because what is I? I equal to V upon R. So we are getting a quantity in the denominator. I equal to, so I'll write it here. I equal to V upon R. So naturally, the circuit will have some resistance. So the current is going to be less. But Jagadish,
Sir,
now you tell me, is there any difference between the phase of voltage and current?
sir, same, sir.
Same. Then why should we go to, if you want to mark, now you tell me where we will mark the current. Current is in phase with the voltage. So what we do, we will just mark it here. This is on the same phase only, in phase with the in phase with the voltage. So that is going to be I naught. That's Im. This is the Im. So Jagadish, this voltage and current are in phase. So see this phase is phi is same for both voltage and current, and the magnitude of current is comparatively less when you compare it with the voltage. So this is going to be the phasor diagram. But simply, if we want to represent, we need not to draw this way also. If we assume that, we are not assuming actually, if we draw, this is Vm. then simply we can draw it. There is no phase difference between these two lines. These are two horizontal lines. This is IM. That's it. This is also simple phasor diagram. This is how simply we will draw it like this only. But once you know the other one, the first what we drawn, this one, then you will not have doubt. You will be more clear about it. Then what is there? See, once you get this, okay, I think so much not required to go. Now, waveform also we will try to draw. 1 second, my daughter. 1 second, I'll be back. Okay. So now, Lakshmi, are you there?
Sir.
Let's try to draw the waveform for the purely resistive AC circuit. So, to draw waveform, we will have the time axis, then the y-axis, that is the amplitude. So we can draw it. First I will draw the current. Not current, voltage. Yeah. So what is the equation for this waveform, Lakshmi?
Peak equal to?
V peak, no. V equal to, that is the instantaneous value.
VM equal to?
Not VM. V equal to the Vm sin omega t.
VM sin omega t.
The Vm is the peak value. V means simply when you say V, that is the instantaneous value.
Okay, sir.
Related to AC circuits. Now this is the voltage waveform. So the current waveform also, it is going to be same waveform but lower in value.
Lower value.
But when the voltage reaches maximum, current also should reach maximum. When voltage reaches 0, the current should reach 0.
Should be 0.
So this waveform is the
Current Im sin
omega t. Im sin omega t. We need not to go this much detail. One more circuit we will see in detail so that you will get the idea. After that, we will just write the equations and move forward. Next, we are going to see a pure inductive circuit. A pure inductive AC circuit. Pure inductive AC circuit. This equation also we will try to derive the relation between the current and the voltage, and after that we will just write the equations. That is sufficient once you get the idea. So we have a circuit, pure inductor is there, and what is there? We are applying the alternating voltage. So this is equal to V equal to Vm sin omega t, and I am at an instant, I am assuming that the current flow, I am in a one particular time of instant, I am assuming current is flowing like this. Why? Because this alternating current will be keep on changing. And now, Anushri.
Sir.
Anushri, now current is flowing in this direction. Okay.
Okay, sir.
And we are applying a alternating voltage to an inductor. So there has to be a self EMF.
Ah.
EMF has to be induced in the coil. Okay.
Okay, sir. Ah.
What will be the polarity as per Ohm's law, or as per the Lenz's law? What will be the polarity of this induced EMF?
Negative.
Now this here. Tell me here. This point what will be? This point what will be? Here what it will be? What is going to be here? Is negative or positive?
Negative.
Here what is here and what is there?
Sir, we studied induced EMF is equal to minus L di by dt.
That is okay. What I simply asked, what is the polarity of the EMF induced? The
Polarity
current
of
is okay.
negative.
Okay. Okay. I see.
Negative polarity, sir.
Here, let me ask one
Positive,
more.
sir.
One
Positive,
more.
sir.
There. This is who Sheikh Altaf. Altaf.
Sir.
Altaf. So you are telling it is positive.
Same polarities are repel each other.
See, that is what. See, this is the plus. Because current will flow from higher potential to lower potential. And as per Lenz's law, this induced EMF should oppose that current flow. That is possible only when this end is plus and this is going to be negative. So here we will get a induced EMF, that is E equal to L di upon dt. Di upon dt. Now, Jagdish, are you there?
Sir,
Jagdish, this much you explain what I told.
sorry, induced in.
No. Now what I want to know, why I mentioned the polarity like this.
Sir.
Yeah.
Sir, induced voltage equal to di by dt.
That is fine, but why? How the polarity, inductor polarity is becoming plus and minus?
Sir, like means like poles is repel each other, unlike poles is attracting.
Not simply don't say like that and all. See, because the current is flowing like this. Okay, the current, Jagdish, the current is flowing like this. So as per the Lenz's law, this inductor will oppose the direction of the current flow, because this current, the changing current is producing EMF in the inductor. That produced EMF should oppose the cause produced it. What is the cause producing the induced EMF? Jagdish, what is the cause producing the induced EMF? Okay, let us ask Sumit. Sumit, are you there?
Yes, sir.
Sumit, these are the fundamental things you have to understand. Okay, now the current is flowing like this. Okay, this is a changing current that will induce EMF in the inductor.
Yes, sir.
What will be the polarity of induced EMF? Why this is plus and this is minus?
Sir, because of V sin omega t voltage source.
Okay, no. See, and now we have a resistor. Okay, we have a resistor. Here we have 5 volt. Here I have connected to 1 volt. This let it be 1 ohm resistor. Sumit, what will be the current flowing and what is the direction of current? Left to right or right to left? Left to right. Why the current should flow from left to right?
Sir, higher potential to lower potential.
Higher potential to lower potential. Okay. Now, if I want to oppose this current flow, what I have to do?
Sir, resistance increase.
Okay, that is one method. Another method is this potential. So
Voltage,
left side, this potential.
will be same on both sides.
Now voltage should be same or see now. Now let me see. This is 1 volt. What is the current flows through this resistor? What is I equal to?
V upon R.
You tell me the V upon R. What? Okay. Sahil, are you there? Sahil? Mohanda, are you
Yes,
there?
sir.
Mohanda, tell me what
Yes,
should
sir.
I write now?
Sir, V is equal to 4 आएगा ना?
That is, see, potential difference you have to take. So 5 volt minus
हाँ, sir.
1 volt. This topic
1
you have to
volt.
finish by tomorrow's class because this fundamental, once you get it, I can finish it. So this is R is 1 ohm. So what is the current flowing through this? 4 amps. 4 amps. Now, this who is there? Shafian, are you there? Shafian, are you there? Shafian, are you there? Naveen, are you there? Naveen?
Yes, sir.
This is who? Naveen.
Yes, sir.
Okay, Naveen, now this is 3 volt. Now what is the current going through this?
High potential to lower potential. 5 volt to 3 volt.
So what is the current? Now you have to look at and tell me what is the current. Very simple now. What is 5 volt minus 3 volt? 2 volt. 2 volt upon 1 now. 1
amps.
2 amps. So now, compared to the previous circuit, this circuit, what is happening? When the potential difference is small, current is decreasing. Dheeraj Shivang, okay. Dheeraj Shivang,
Yes, sir.
are you there?
Yes, sir.
Dheeraj.
Yes, sir.
Now, you are seeing that here we have a 5 volt source.
Okay.
This is 1 ohm and this is 5 volt. What will be the
sir.
current flowing through this circuit?
Sir, 0, sir.
0. Because the potential is saying there is no current flow.
Yes.
Similarly, this inductor, what is happening? See here, this is a plus. This terminal at a particular instant, this voltage, so this terminator is plus. So current is flowing from higher potential to this way, higher potential to lower potential it will flow. Due to that current flow, there will be induced EMF in the coil. That induced EMF should oppose the cause. Cause means oppose the reason for that induced EMF. The reason for the induced EMF is this current. This current is the reason for the induced EMF. So to oppose that current, what will do? This inductor will produce plus here. So now once plus is here and here also plus is there, then definitely the current flow reduces. How it will come? Now it will come like a 2 circuits. So that means, so here I will have a polarity. I can replace this E by a polarity. One small battery, this E. And the this is the E. And again, what is there? One voltage source is there. If we connect like this, what happens? This is in the opposition. This is connected in the opposition mode. That is how the inductor opposes the cause. Inductor voltage induced EMF opposes the cause producing it. Okay. Next, okay, this is voltage across. This is E we got. Now we can write it as V is the voltage, V minus E equal to 0. Anushree, is it right what I wrote? Anushree, are you there?
Sir.
Is it correct? How I wrote, Anushree, this? V minus E equal to 0?
Sir, I think it is not right.
Why it is not right, you have to tell.
E is the induced EMF. V is the applied voltage.
Yeah. See what you have learned in the KVL. I am applying KVL here, that's all. Applied voltage equal to voltage drops in the circuit. Here this is an inductor. So my voltage drop is going to be E, small e. Then I can write. Correct?
Okay, sir.
Yeah, that's how I wrote. I applied KVL there. Now we will just try to simplify it. V equal to L di upon dt equal to 0. Now L di by dt equal to V. Instead of taking minus L di by dt towards the right side, I wrote it on the left side. That's it. So what is di here? Di equal. Lakshmi, what is di?
VL. Sir. VT by L.
What's di?
Instantaneous current.
No, correct only. Current. So how do I simplify? I'll write it as I will cross multiply.
Sir.
So I'll get V upon L.
V dt by L.
V dt by L. So here, so di equal to Divya. Are you there? Divya. Let's simplify this. Di equal to what, Divya?
Sir, V by L.
V, what is our now? We will put the value for V. V equal to V naught sine omega t upon L dt. Now again I'll write it as di equals this V naught upon L is V naught upon L. One second. Okay, di. Divya.
Yes,
Divya. Now let's simplify. Di equal to, I write this V naught upon L sine omega t dt. Now from this, if you want I, what do you do? Divya? I equal to what? See now, I equal to how many? Di equal to V. Some sound is. Divya, please mute your mic. Some noise. Okay. And now you try. Divya, are you there?
Yes, sir.
Oh no, some noise is coming. Okay, please mute. Okay, then who will be with me? That is Aradi. Are you there? Aradi or Radira?
Yes, sir.
Okay, this is
Arati.
Aradi. Now we have a equation for di equal to V naught L sine omega t upon dt. What is I? So this V naught upon L is a constant. So I will write it first. Andira, what is the integration of sine omega t dt? That is minus cos omega t upon omega. So this is our integration of sine omega t. Now we got the equation for I. So next what I will do, I equal to V naught upon omega L. And what are you left with? Left with cos omega t. We are left with cos omega t. So now we have one trigonometry equation. Actually, we are not going to learn the derivations, not required for you. But once we go through this, then we can proceed faster. How you will understand, you will have a thinking how this comes. So we have an equation that is sine of minus theta. Sine of minus theta equal to minus sine theta.
Sir,
Yeah.
sir, above line sin omega t dt not writing below.
Actually, no. That is we have integrated here. Integration I do not write here. Integration. So when you integrate di, we will get I. When we integrate sin omega t dt, we will get cos omega t minus cos omega t upon omega. Now what we need, we got the cos omega t. So here, okay. So next I will write I equal to Jagadisha, are you there? Jagadisha? Chandru, are you there? Chandru?
Yes, sir.
Chandru. Now, this V naught upon omega L, what you can write? What is this omega L?
Omega is.
What is this omega L?
So omega is
What is 2 pi FL?
omega by L.
What is 2 pi FL? What is 2 pi
Inductive
FL?
reactance, sir.
Inductive reactance. So this is like a resistance. So V upon resistance. What is the unit of inductive reactance? Akhil, are you there? Akhil?
Yes, sir.
Akhil, this V naught upon omega L. Omega L is what?
2 pi FL.
2 pi FL. What is 2 pi FL? It is the
Inductive
inductive reactance. What is the unit of inductive reactance?
Ohm.
Ohm. So the V upon, we have a resistance quantity in the denominator. So we can write it as I naught. See, I naught, see this V naught or Vm also we can write. It is a peak value only. I naught also we can represent it. Okay, so we got V naught, no, I naught minus cos omega t. I naught cos omega t. So, but for the comparison, we want it in sine. Cos omega t. So this one, what we can write? I equals, this is a minus sign, okay, minus sign. We have I naught minus cos omega t. So minus I naught, let it be there. This cos omega t, we can write it as sine omega, sine pi by 2 minus omega t. And then from this minus sine theta, see here sine this here we have sine minus theta equal to minus sine theta. So it is in the form of, now what we have to do? So I equals, what is the equation we have here? It is sine of minus theta equal to minus sine theta. So whatever we have here in this equation, it is in the form of minus sine theta. So I will apply this minus inside this bracket. When you free, if you can just try it out when you are free. So what I will get? I naught sine omega t becomes plus. So because I am multiplying with minus pi by 2, I will get it. You need not to derive this equation. This is just for the to get the thinking how it is coming, this voltage and current. Now the next circuits we are not going to derive at all. So now who is there? Nishant, are you there? Nishant? It's not, so just to verify. Nishant. Okay, Anushree, are you there?
Yes, sir.
Anushree, Now, the one equation is the waveform, voltage waveform equation, V naught sine omega t. And the current waveform we got as sine omega t minus pi by 2. From this, what is the phase difference? How do you identify the phase difference, or what is the phase difference?
180 degree.
180 degree. 180 degree, how do you say in terms of pi?
Pi is equal to 180 degree.
Okay. Let's, Meenakshi, are you there? Meenakshi, are you there? Sidhu, are you there? Sidhu? Jaimon, are you there? Dheeraj, are you there?
Yes, sir.
Dheeraj, now you tell me the difference between these two equations. We were knowing the voltage equation, and that voltage we have applied to an inductor. From that we have derived the equation for current. Okay. Now you tell me what is the phase difference between these two waveforms, voltage waveform and current waveform.
Sir, pi 2, sir, minus pi by 2.
That is means what is leading, what is lagging?
Sir, voltage leading, current lagging.
That is minus pi by 2. So current is lagging. So I will write it here. Current lags behind will say, won't say, lags by, current lags by 90 degree. So in an inductor circuit, current lags by 90 degree circuit. It's a pure inductive circuit. There is no resistance involved. Now let's try to draw the waveform. Waveform is difficult to. Okay, let me try. What are the equations we have? That is V equal to Vm sin omega t, and I equal to, we can write V naught or Vm, it's same only. Im sin omega t minus pi by 2. These two equations we have. And if you try to draw the wave diagram, this is a little difficult for me to draw. Let me try. So this is the voltage waveform. Now how do we check whether this is correct or not? This is Vm sin omega t. Vm sin omega t. So how do we know whether it is correct or not? If you put in this equation, the voltage equation, if you put t equal to 0, what do you get? We will get 0. So at time t equal to 0, we are getting 0. But what about in the current waveform? Current waveform, now this is here, if I put t equal to 0, what we get? I put t equal to 0. Who is there? Adira, are you there? Adira?
Yes, sir.
Adira, in the current equation, if I put t equal to 0, what do I get? What value I get?
T equal to 0, 90 degree only. Only 90 minus 90 degrees, sir. Sin 90 degree.
Sin 90 degree I will get. So minus of sin 90 degree I will get. So at t equal to 0, I should have a value somewhere here. My value should be here. Then, so you should start like this. Yeah, yeah.
Zero.
It can be zero, no. This axis is the amplitude axis. This is the amplitude axis. Amplitude. So when time equal to zero, it is not correct. Voltage is lagging.
No, sir. Voltage
Yeah.
is leading.
Voltage. Sorry, voltage leading.
Current.
Yeah, it is correct only. No, it is minus Im. It is minus Im. Then, if you try to plot what happens when this is 90 degree. Now, when the voltage is zero, okay. Now, this drawing diagram I will show you tomorrow. Let me practice properly and I will show you. Then, okay. Now we will try to draw the phasor diagram. Phasor diagram drawing is very easy. Now we will try to draw the first phasor diagram. Then we will draw the second one. Jagadish, are you there? Jagadish, are you there? Phi equal to omega t. Lakshmi, are you there? Lakshmi, no. Divya, are you there?
Yes, sir.
Divya, now I want to draw the phasor diagram for it. Divya, what some noise is coming from your microphone. Okay, Divya. Now this let it be VM. VM. Now where should be IM? Divya, are you there?
Yes, sir.
Where should be IM? Now, this is a purely inductive circuit. You know that voltage leads by 90 degree. Current lags by 90 degree. So now, so what is there? Next, this is VM means IM should lag behind. This is IM. This is IM and this angle is going to be 90 degree. This angle is going to be 90 degree. So here the current is lagging behind the voltage by 90 degree. So see, now onwards we are not going to draw like this phasor diagram. Now you might have got the idea how to draw the phasor diagram in a simple way. If this is VV, this is VM, or we can say V. This is VM. Then how to draw IM, the phasor diagram representation? It is just 90 degree, just 90 degree. This is IM, and the angle is always going to be, we will take it in the anti-clockwise direction. It is going to be 90 degree. So here voltage is leading and current is lagging. Next we will go to the pure capacitive circuit. Pure capacitive circuit and all we are not going to go in depth, because now you might have got at least somehow it is pure capacitive circuit. Pure capacitive circuit. In a pure capacitive circuit, we have a capacitor. And we are applying a alternating current to it. That is Vm sin omega t is what we are applying, which equal to V. and there will be a voltage drop across this capacitor, that is going to be Vc. And if you do the calculations similar way what we have done, we will get I equal to Im sine omega t plus pi by 2. We will get an equation. Now Lakshmi, while looking this, Lakshmi,
Sir,
by looking at this diagram, can you tell me how the voltage and current are related, and how should I draw? What happened? Hello, Lakshmi.
hello.
Yeah. Tell me how the voltage and current phases are related.
180 degree.
How I not understood 180. Why? How do you say 180 degree? See, what is the phase difference? Phase difference equal to mode of phase of voltage, that is omega t minus omega plus pi by 2. This is the phase. Now if you simplify, what you get?
Omega t minus omega t. Sorry,
Cancel.
90 degree.
Minus, we will get pi by 2. This pi by 2 equal to what? 90 degree.
90 degree.
90 degree. That is how you have to compare 90 degree. 90 degree. See, omega, with omega t, what is added or what is subtracted? That is the phase difference.
It's different.
Yeah. So in a pure resistive, a pure capacitor circuit, we will say what we can say. Current leads.
Current leads the voltage by 90 degree. Capacitor circuit.
Current
Leads the
leads voltage
by 90 degree.
Voltage by 90 degree. Voltage by 90 degree. Voltage by 90 degree. Current leads voltage by 90 degree. That's all you have to remember from here. Then what about the phasor diagram? Wave diagram I will try to draw. Wave diagram drawing, little practice required. Phasor diagram, this is the VM. This is the VM. Usually peak value only we have to draw the phasor. Now, who is there? Altaf, are you there?
Sir,
Altaf, I should, where it will come IM? Top or bottom? You tell me, in the first quadrant or the fourth quadrant?
what?
Quadrant means what?
Top, sir. Top, sir.
Quadrant. See, this is the we have the trigonometry. This is the first quadrant,
Bottom.
second quadrant, third quadrant, and fourth quadrant. Okay. Now, which quadrant it will come? Altaf.
Current
Sir,
is
which
lagging,
quadrant?
but fourth quadrant, sir.
For that perpendicular line. Which one? Fourth.
Fourth one, sir.
Okay. Fourth, let me ask somebody else also. Dheeraj, are you there?
Yes, sir.
Dheeraj. Now we are trying to draw the phasor diagram. If this is the
Yes, sir.
circuit voltage, I have represented by a horizontal line. That means it is a 0 degree in phasor. Now, the current waveform, where it comes?
Yes, sir.
In the first quadrant,
Sir, first quadrant 90. Yes. Upper side.
Why you should come there?
First.
Why you should come up? Why you should come upper side?
Sir, it is current is leading by 90 degrees, sir. 90 degrees.
Yeah. It is because current is leading by 90 degree. See, this is the IM, and how angle we will take it like this only. Anti taking out in the phasor diagram anti-clockwise. This is Im and angle will take in the anti-clockwise. So there is a 90-degree lag between the two. 90-degree lag between the two. So this is about the capacitive circuit. Anything else I have missed here? Here we have come across two terms. That is XL. XL Chandru, are you there? Chandru, what is XL?
2 pi FL, sir.
2 pi FL, or other way what we can write? Equal to what? What is this 2 pi F? 2 pi F means what? It is omega. This is the omega means angular frequency. To F omega L. And similarly, Chandru.
Yes, sir. Hello.
XC, if you want to derive that capacitive current relation, yeah.
1 divided by 2 pi FC, sir.
1 divided by 2 pi FC equal to, how can we write?
1 divided by omega C, sir.
1 divided by omega C. This also you should know. You should know anytime you should be able to tell these things. Simple problems will come based on these things. Okay. And next we will come across the RL circuit. RL series RL circuit. Okay. We will go through the RL circuit. The remaining topic we'll study tomorrow. RL circuit, series RL circuit. Anishri, are you there?
Sir.
Anishri, are you there?
Sir. Yes, sir.
Anishri, what is the time constant of a RL circuit?
L by R.
L by R. Okay. So here we are going to learn about the series RL circuit connected across a AC voltage source. So here we will apply VM T. So this is R and this is L. So voltage drop across R is given by VR and voltage drop across L is given by VL. So once we know that, this let be V. Now who has to tell? Minakshi, are you there? Nishant, are you there? Nishant. Naveen, are you there? Naveen?
Yes, sir.
Prasad, are you there? This is who? Naveen.
Yes, sir. Naveen.
Who? Naveen. Naveen, let's write. Now, you tell me as per KVL, what I should write. Apply KVL for this circuit. Naveen, what is
Hello.
what KVL says? Hello, yeah, yes, I can hear you.
Sir, cable means supply voltage equal to drop voltage.
Then you tell me what should I write here?
V equal R plus L. Hello.
Yeah, tell me. Okay, we will ask this one. Jaimon, are you there? Divya, are you there?
Yes, sir.
Divya. And now, just apply KVL here. in this loop? How do you write? V equal to what?
VR plus VL.
VR plus VL, because applied voltage equal to sum of voltage drops. And this V, how can we write it? This V?
VM sin omega t.
No, here we don't want to get into such a detail. So here, okay, here what you do, the phasor diagram, we are going for the phasor diagram. We will draw the phasor diagram. So we will draw the phasor diagram. So here, this is VR and VL, two voltages are there. We can't simply write like V equal to VR plus VL. It is correct only, but we have to use the phasor diagram. So this let it be the voltage, VR voltage. If that is VR, the current through the resistor is in phase with the voltage across the resistor. So it is IR. Now Divya,
Yes, sir.
now this VL comes where it comes. It is in the first quadrant or fourth quadrant. Which side it comes, up or down?
So fourth quadrant.
Now, what do you know about the inductor?
Opposed to any change in current.
No. What is the relation between inductor current and voltage? Divya, what is the relation between inductor current and voltage? I will draw it down here. Down only you told, no? Here,
Yes,
correct. So now I will mark it as VL.
Voltage is leading by current in 90 degree.
This is what you told, no? Correct.
Yes, sir.
Now what Divya, you tell me whether it is correct or wrong. Let us try to analyze. Okay, in the inductor circuit, the current should lead. Current should not lead. Current should lag. Voltage should lead.
Yes, sir.
Correct. See here, the current is we will take the reference of the resistance current. See here, if you compare the anti-clockwise only, we are taking the angle. So if you move like this, then the current and the voltage is leading here. Correct. Divya, you understand? See, this is our voltage across the resistor. Voltage across the resistor. And so easily we can write what is the current through the resistor. The current amplitude is going to be a smaller value and the direction is going to be same. Now you told voltage is here. Now with this, if you compare what you have learned, whether it is matching, Divya?
No, sir. Voltage is first quadrant and current is fourth quadrant.
See, current is already we are taken as a reference here, but it can't be here. If we take like this, what is happening? If we take like this, what is happening? We will take the angle in the anti-clockwise. Here, the what is leading here? The current is leading here. Circuit current is leading. That is not possible in the case of inductor. So this is wrong. So then what you have to do? Now we will draw it upside. So here we will mark it. What is that? VL. Now it is matching. In a inductor, the inductor voltage VL is leading the current IR. IR means it's a circuit current only. It's a series circuit, no? Same current should flow. So that current is, IR means it is a circuit current only. That is leading the voltage current by 90 degree. Now it is matching. Now we have the phasor diagram for voltage and the resistance, voltage across the inductor and voltage across the resistor. Then what you have to do? We have to do the phasor diagram. We have to so what about the magnitude? Magnitude. This is the Divya. This is like a vector sum. If I this is like a vector sum. Okay. If this is the vector sum and this whatever the line which I have drawn from the origin, that linear line, that is the resultant. Then what is that resultant? Divya? Divya.
Yes, sir. Sir.
Now what I am doing? We have the voltage across inductor, that is VL. Then we have the voltage across resistor VR, and we have to add it vector. This phasor diagram is it's a kind of vector only. So vector by vector we have to add it. So VL plus VR, this is the magnitude. This is the resultant. This is the result. What is the result we will expect to get, Divya?
Sir, VM sign.
Yeah, it should be V. Our result should be V as per the KVL. Now we have to, whenever two components are there, we have to follow vector addition. So we can write it here. Where is it? V square equal to VL square plus VR square. Now we can write what is V square. What is V square, Divya? How can we write? It is V square only. V square. VL square we can write it as I square. What I will write? Chandru, are you there? Not Chandru. This Prasad, Meenakshi and all, where are they? Are you there, Prasad, Meenakshi? Sahil, are you there? Sahil, are you there? Just 5 minutes we'll wind up. Sharon is not there. Then Dheeraj, are you there? Dheeraj? What about Mohanda?
Yes, sir.
This is who?
Mohanta, sir.
Mohanda.
Sir, Dheeraj, sir.
Okay. Mohanda, V square equal to I square. What should I write there?
I square into R square.
What? Current into resistance. V equal to I into R. V equal to I into R. Now, for VL, what should I write? I square?
I square into XL square.
XL. Plus, for VR, I can write it as I square R. I square R. Now, this I, how V square equal to I square multiplied by XL plus R. Now what is here? Now I will take the I to the left side, that is V square upon I square equals XL plus R. What is now V by I? What is V? Square is there? No, XL square R square. So here also that is not whole square. Anushree,
Sir.
how do I write here? It is XL square.
V square by I square is equal to R square.
V square by I square is equal to XL square plus R square. Here I forgot to put the R square and XL square. So now V square by I square we have V
R square.
V by I we need. What is this is equal to square root of
R.
XL
square.
square plus R square. So what is V upon I, Anushree?
R resistance.
V upon I, V by I equal to R. This resistance in a AC circuit we say it as impedance. So here V upon I equal to XL square plus R square. That is equal to
Z is equal to square root of R square plus XL square.
Z equal to square root of R square plus XL square. This is the impedance. Z equal to impedance. Chandru, are you there?
Yes, sir.
Chandru, are you there?
Yes, sir.
Altaf, are you? Chandru, what is impedance?
Hello.
Hello. What is the unit of impedance?
Sir, ohms.
Ohms. Also, this is the equation of a RL circuit. Similarly, we have to find for RC circuit and LC circuit, and then we can go to the series resonance circuit. Parallel circuits are not so important for you. Later we will come back to parallel circuit after some more classes, so that you will be much in a good position to solve the questions. Once more, anything else I have to write here? And here, one more thing you have to remember in a LC circuit. What is the LR circuit? RL circuit. Cos phi equal to power factor. Cos phi equal to power factor, and that is given by R upon Z. And this power factor value should be always less than 1. So this is also an important equation. This is required power factor equation, that is R upon Z. Then in a AC circuit, power is given by power. When you say simply power, it is average power, that is VI cos phi. VI cos phi. VI cos phi. This equation also you have to remember. In the remaining circuit also, this equation will be keep on repeating. So I think today we will wind up. This one you have please go through these things, try to understand, try to write yourself. So this much once you understood, tomorrow we can proceed. Tomorrow we will finish quickly, because we need only the this impedance equation, what is the power factor equation, and one more is there, what is the phase equation. So such equations are sufficient from this AC circuits to get you the idea how it comes. That is why we have gone for this equation derivation. Okay, then thanks guys, we'll wind up today. Anything else?